So we're graphing inequalities, and the number one most common mistake, we're solving and graphing inequalities, sorry. And the number one most common mistake that kids make when they go ahead and solve these inequalities is they forget to flip the inequality whenever they multiply or divide by a negative sign. I'm going to say that again. The number one most common mistake kids make when they're solving inequalities is they forget to flip the inequality whenever they multiply or divide by a negative. So our first question here is negative 10 is less than or equal to negative x. It's a very straightforward solution here. I really have a negative 1 sitting in front of that x, and it's multiplying the x. So in order to undo that, I want to divide both sides of the inequality by negative 1. Negative 10 divided by negative 1 is a positive 10. I have to flip the inequality, and negative x divided by negative 1 is positive x. The thing about inequalities is they can be read in both directions. I can either read this as 10 is greater than or equal to x, or I can read it as x is less than or equal to 10. It doesn't matter which direction I go in when I'm reading this. At any rate, I want to graph this inequality, the solution to it, x is less than or equal to 10. Now, some teachers are pickier than others. I'm not all that picky. You want to create a number line that represents the x-axis. I do want to know where 0 is, just as a point of reference. And 10 is obviously to the right of 0. With less than or equal to, we put a circle around the 10 because that's our boundary, and we close it in because 10 actually works. If this were strictly less than, I would not close in that circle. But since it's less than or equal to, I do close it in. And then I just ask myself, what x values are less than 10? And they are numbers like 9 and 8 and 7 and 6 and 5 and negative 53 for argument's sake. Anyway, all of them exist on the left-hand side of my boundary, which is 10. This right here is a correct representation of that inequality. So we have some others to do. Solve the inequality and graph its solution. I have negative 8 is less than or equal to x minus 14. Well, I want to get x alone just as I do with any other type of linear equation solving. So I'll add 14 to both sides of this inequality. Negative 8 plus 14 is 6, less than or equal to x. And again, you can read this in two directions. You can read it as 6 is less than or equal to x, or you can read it as x is greater than or equal to 6. When you go ahead and graph it, you create a number line, which again represents the x-axis in this case. I want to know where 0 is. 6 exists on the right-hand side of 0. Since 6 is my boundary, I put a circle there. Because it's less than or equal to, I close in the circle. And then I want to know what numbers are greater than or equal to 6. Well, they exist to the right of 6. Numbers like 7 and 8 and 9 and 10 and 5 million, for argument's sake. So I shade to the right, and I put an arrow there indicating that all of those numbers are in my solution set. The next problem says negative 10 is greater than a minus 6. It shouldn't surprise you that I'm going to add 6 to both sides of this inequality. And when I do, I'll have negative 4 is greater than a, or I could read that as a is less than negative 4. It doesn't matter. This number line represents the a-axis. I want to know where 0 is. Negative 4 would be to the left of 0. This time, when I circle my boundary, I don't shade it in because a cannot equal negative 4. It has to be less than negative 4. What kind of numbers are less than negative 4? Well, they exist this way. Now, I want to point something out with this particular example. Somewhere along the line, usually in elementary school, you learn to shade in the direction of the arrow. Well, this isn't an arrow, it's an inequality sign, first of all. And secondly, that rule only works if your variable is on the left-hand side of the inequality. In real math, your variable is not always on the left-hand side of the inequality, as is the case here. I want a's that are less than negative 4. You actually have to think about where they exist on the number line. You can't just use some silly trick that says go in the direction of the arrow. All right, and here's our last one. I have negative 18.2x is greater than or equal to negative 91. So I'm going to divide both sides by negative 18.2. And I will end up with x is less than or equal to, oh gosh, what is that? 80, 96, 7? I don't have any idea. So back we are. The answer is 5 in this case. And when I create my number line, again, this number line represents the x-axis this time. I want to know where 0 is. Here's 5. I've got my boundary at 5. I want to shade it in because it's less than or equal to. And all the numbers less than or equal to 5 exist on that side of it. I put an arrow at the end of the shading indicating that the solution set goes on forever. All right, and that's graphing inequalities in a nutshell. Do not forget to flip the inequality when you multiply or divide by a negative sign.